Astronomers have just revealed the first image of the supermassive black hole at the heart of our own Milky Way Galaxy, known as Sagittarius A. But this image from the Event Horizon Telescope, or EHT, is unlike most other familiar astronomical images. It's the product of technically challenging telescope observations and innovative data processing that tackles the unique complexities in EHT data. The fundamental challenge is one of scale. The Sagittarius A black hole is about 4 million times more massive than our Sun, extending over an area almost as large as Mercury's orbit. That may sound large, but at a distance of 27,000 light-years, this is like trying to take a photograph of a single grain of salt in New York, all the way from Los Angeles. You would need a radio telescope as big as the entire Earth to take a picture of something that small. Constructing a telescope dish that big is of course impossible, so astronomers got creative. They developed algorithms that combine radio telescopes across the globe into a single virtual Earth-sized telescope. This computational telescope, the EHT, doesn't work like a regular telescope. Instead, the radio telescopes work in pairs, with each pair contributing a little bit of information to the entire image. Telescopes that are far apart can detect the smallest, sharpest features. Orientation is also important, with each angle picking up different parts of the whole. With enough samples, you can recover all the sharpest features. Telescopes that are closer together become sensitive to broader features that the wider pairs can't see. Combined, these components of the image can provide a good representation of the target being observed. Making a perfect image would require telescopes at all orientations and separations. But EHT's 8 telescopes scattered around the globe only measure some of these possible pairings. Luckily, as Earth rotates, the separation and orientations between the telescopes change, providing more, but not all, of the information we need to make a perfect picture. In essence, taking a picture with the EHT is a bit like listening to a song being played on a piano that has a lot of broken keys. Since we don't know when the broken keys are being hit, there are an endless number of possible tunes that could be playing. Nonetheless, with enough functioning keys, our brains can often fill in the gaps to recognize the song. And on top of all of this, in the case of Sagittarius A, there was another daunting challenge. The material swirling around the black hole moves so quickly that its appearance could change from minute to minute while the data were being collected. This is a bit like changing the key of the song as it's being played on the broken piano. To tackle this and other challenges, scientists and engineers have spent years developing computational imaging algorithms that allow us to capture images of the black hole with incomplete data. These algorithms can intelligently fill in the missing information in a number of different ways. To capture the range of possible Sagittarius A appearances, the EHT team produced thousands of images with different methods. Each of these images is slightly different, but they all are consistent with the EHT data. By averaging these images together, the team emphasized the common features appearing in most of the images, while suppressing features that appear infrequently. Here, a bright ring clearly pops out. But it's important to note that not all the possible images look alike. In fact, the team found they could cluster the recovered images into 4 categories based on similar visual features. 3 of the clusters contained a ring-like feature with different intensities around the ring. A much smaller 4th cluster contained images that did not appear ring-like. Although the non-ring images can't be fully rolled out, the vast majority of the images contain a ring of exactly the same size predicted by prior observations and theory. Through the power of computational imaging, the EHT team overcame seemingly impossible hurdles to capture the first image of Sagittarius A. In the future, with more telescopes and better algorithms, we aim to get an even clearer picture and a deeper understanding of the beastly black hole lying in the heart of our galaxy.